Welcome. In this video, we're going to solve an optimization problem, and we're going to use the 6-step process for solving optimization problems. These are the 6 steps we will follow for solving optimization problems. Step 1, make a sketch. Use that sketch to identify the objective and constraint functions. Step 2, combine the constraint into the objective function. Step 3, find critical values of the objective function. Step 4, confirm critical value is desired max or minimum. I should add here to step 2 that you are required to reject any unrealistic critical values. For example, you cannot have negative fencing for a perimeter. Step 5 then is to use the remaining critical value in the constraint to solve for any unknowns. And then step 6, answer follow-up questions. Problems. So find the point xy on the graph of y equals square root of x minus 1 nearest the point 5, 0. And the first step is to make a sketch. And that's here. So as you can see, I went ahead and sketched y equals the square root of x minus 1. And then here is the point 5, 0. And we want to find what point on this blue graph is closest to this point here along the horizontal axis. So let's begin with our objective and constraint. So the objective is to minimize the distance. So we need to recall the distance formula. That is d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. And this is the distance between points x1 comma y1 and points x2 comma y2. Now minimizing this will be a little tricky because of the square root. So then rather than minimizing d, let's minimize capital D, that is equal to d squared, which is x1 minus x2 squared plus y1 minus y2 squared. Now one of these points, that is xy, on this curve is unknown. We don't know the x value nor the y value, and it may not necessarily be right above 5. I just drew it in any spot. So that is unknown, but we do know this other point, that is this is 5, 0, and that point is known. So we are minimizing big D equals 5 minus x quantity squared plus 0 minus y squared, which just simplifies to 5 minus x quantity squared plus y squared. What about the constraints? Well, our constraint is y equals the square root of x minus 1. Okay, now let's move on to step 2. And in step 2, we are going to combine the constraint into the objective function. So our objective, again, is 5 minus x squared plus y squared. So I can substitute this y, that is the square root of x minus 1 here, to get 5 minus x quantity squared plus x minus 1. And now this is a function of x, so I'm going to make that abundantly clear by writing this as d of x. Now we're going to find the critical values in step 3. That is, we're finding the critical values of this new objective function. So we write d prime of x is equal to 2 times 5 minus x times negative 1. And that's just applying the power rule and the chain rule. And then we're going to add 1 for this derivative, and I'm just going to ignore this because this will vanish as its derivative is 0. A little bit of rewriting yields 2x minus 9. Now for step 4, let's take a moment and confirm. Now all that is left is to set 2x minus 9 equals to 0, which only holds when x equals 9 halves. All right, this leaves us poised at step 4, which is to confirm that the critical value, the remaining critical values, and in this case we only found one critical value. So in this step we're to confirm this critical value is the desired minimum or maximum. In this case we want a minimum since we're trying to find the point on this graph that is nearest to 5, 0, so we're minimizing distance. And to do so, let's again start with our number line. Here is 9 halves. I think we'd all agree that this is equal to 4.5, and to the left of 4.5 is just 4, and to the right is just 5. So let's see this, that is, let's find the sign of the first derivative of our objective function evaluated at 4, and the first derivative of our objective function evaluated at 5. So d prime of 4 is going to equal 8 minus 1, which is negative 1, so this is less than 0. D prime of 5 is going to equal 10 minus 9, which is just 1, so this is greater than 0. As the slope to the left of 9/2 is decreasing, and the slope to the right of 9/2 is increasing, it's clear that this will form a minimum at 9/2. Now that that is done, we can use the critical value and our constraint to solve for any other unknowns. And in this case, we're looking for y, since we need the point x, y closest to y equals the square root of x minus 1, and we only have the x value. So let's go ahead and find the y value. So we have y equals the square root of x minus 1. And substituting x equals 9/2, we end up with 9 over 2 minus 1. So that is equal to the square root of 7 over 2. Rationalizing the denominator, we end up with root 14 over 2. So the point closest to this graph, the point on y equals the square root of x minus 1 nearest 5, 0 is actually 9/2, comma, root 14 over 2. And then finally, we're left with step 6, and step 6 is answer, that is, solve any follow-up questions, but there are not any follow-up questions, so we can just go ahead and emphasize in writing that the point on y equals root x minus 1 closest to 5, 0 is this, that is 9/2 root 14 over 2.